welcome you to our Thursday Tech Talk, middle of August edition. It's summer in the Northern Hemisphere, and in some parts of the world it is very, very hot, but we're going to talk about something very, very cool today. We are going to talk about UFOs, and how we can find out more about UFOs by mining the data, visualizing the data, and showing off some of the really cool skills that you can pick up here at Coding Nomads when you learn Python, when you learn how to use some of these tools. We have got Cagdas Yetkin, who is in red. In my view, he's in my upper right corner. Wave, there he is. So Cagdas will be talking today about visualizing data using Python. He'll be mining a rather large database filled with UFO sightings. This is going to be really cool. If you're into X-Files, if you're into UFOs, if you're just into Python, this is going to be a great talk for you. So I'm going to turn it over to Cagdas. Take it away.
Yeah, thank you. Thank you, everybody. And actually, this is the first half will be about data visualization in general, and then I will slowly start using the UFO data. Let me share my screen. All right. Yeah, so feel free to interrupt me if you have any questions. Later, I guess we will have a section for questions as well. Anyway, welcome to this tech talk about visualization, Python data visualization in particular. It's going to be a little about storytelling, because if you work with data and visualization tools, chances are you will end up with telling stories like I am doing in my daily job. I really like this picture because there are hundreds of thousands of stars, but she is the one who is connecting the dots. And that's what we will try to do in our 1 hour today. So, and also we shouldn't forget, we are living in this interesting era of massive amounts of data. And when it is the case, it's not really difficult to find terabytes, sometimes gigabytes of data every day. So visualization tools can really help you to tackle this kind of challenge. And well, we need to get better at talking, of course, and we always need some dashboards and chart to help us. Before diving deep into this material, I want to tell you a short story about these tools. And first, myself. I am a data scientist at Jabil Electronics Manufacturing, and I am also mentoring at CodingNomads. Some of my past data science projects include car parts manufacturing, pharmaceuticals, supply chain of 5G devices. And these days I am working on electronics components, such like these. These orange guys are representing my machine learning models, trying to figure out if these components are defective or not. In my free times, I like working on sports analytics applications. Later, feel free to contact me using these links. I don't have a useful GitHub link, unfortunately, because at Jabil, we don't push code to GitHub. So yeah, before diving deep into the material, I want to recommend a few readings. I am a fan of Alberto Cairo in visualization. I recommend checking out his books. He's really building amazing infographics. Those are the kind of visualizations you see on news vendors like the Washington Post, the Guardian, etc. You may find useful to check this name called Edward Tufte. He's known as one of the pioneers in this field. And also I want to recommend a white paper about tidy data by Hadley Wickham from RStudio. This paper is not about R programming or RStudio. It's about tidying your data, getting it ready to analysis so that it will help you in your visualization applications. I think you can find them easily. Okay, we said history, right? I want to start with one of my favorites, Galileo Galilei. This is from the Middle Ages, obviously. He was lucky he didn't need to parse datetime strings to datetime objects. He simply wrote it down to a piece of paper. So these are the dates. And this circle is the planet Jupiter. The small stars you see over here are the moons of Jupiter, like Io, Europa, etc. And sometimes they are appearing, sometimes they are disappearing. Obviously, he's trying to show a motion here, and he's trying to make a point. And obviously, Vatican and the Pope did not like that work. This one is from 19th century. The lady is Florence Nightingale. She's known as one of the pioneers in this field, in nursing especially. And he presented this to British Parliament, and she changed their minds. How it happened is that she was sent to the battlefield, actually to Crimea. During those days, Russia was trying to invade Crimea again, and she was there in 1854 September, and she started collecting data. So this is one of the inspirational points I like about her. So she didn't sit around and wait for data, and she went there to the battlefield and started collecting her data points. And she started counting the causes of mortality. The red fields you see in the visualization represent the death caused by battle wounds, and the green ones, the larger areas, represent the death caused by preventable disease, mostly caused by hygiene. So after this presentation, the parliament accepted implementing more cleaning facilities and hygiene, and she saved, I guess, lots of lives. So the last one from the history that I want to share with you is from a doctor called John Snow. He also presented this to the parliament, and he changed people's minds, because until that day, they thought that the cholera was spreading through air, but actually it was from water. And he counted the cases of cholera, and he showed them that the cases are accumulating, concentrating around water pumps. Okay, and we are coming to our era. Until after 1980s, the number of charts we see around increased rapidly. I think these two guys are to blame. On the right-hand side, you are looking at my first computer, Windows 3.1. And of course, having these personal computers, and once they entered into all the offices around the world, it became much more straightforward, especially thanks to Python. And this small drawing is really something that I like, and I show all my friends. After Python, people were simply importing flying, and then they were flying, and the other developers were asking, how do you fly? It's so simple. You just import fly, and then you fly. Python is used, I mean, this kind of visualization is used in science research and business decisions around the world. The one on the left-hand side is directly from the Atlas project, CERN, Switzerland. They are using Matplotlib over there in this research. Perhaps you are familiar with the Higgs boson news. And business people, of course, love looking at dashboards. And also that's what I build in my daily work. Some of my machine learning models are used in some of the visualizations in business dashboards. I placed some links here. Go ahead and check them out. There's also a nice training material by them. Okay, before going into the code, some food for thought. This is not an exhaustive list, but I'm hoping to trigger some thinking here, and hopefully it will learn you more about the topic. First of all, do not start, I mean, I don't recommend starting with the backstory when you have a visualization project. Show them the real thing up front, and it will trigger some questions, hopefully. Otherwise, more people are sleeping. That's my experience. There are always going to be some people sleeping, but you shouldn't lose the motivated ones. Start with the end in your mind, just like Florence Nightingale. So what do you want to do? Because the kind of visualization you will use will change depending on that. Are you trying to sell something, or you have a startup and you want some investor money? So it will change the kind of application you will use. And try to target people's emotions. People make decisions based on emotion. A naive example was the one I tried here. So I placed an emoji here. Of course, this is just a simple one, but by using this emoji, I was trying to target your feelings, actually. And try to learn about these techniques I recommend. And the last I will mention here is avoiding bullshit. There's a nice link here that I want to share with you. This is an official course in the University of Washington. I think I did this material. I studied this material more than 2 years ago. You can learn really great many things in this one, including Hans Rosling. Hans Rosling was one of the pioneers in this field, and his famous video is here. I recommend checking that out. And hopefully this material will help you to think more about the kind of visualizations you want to build. Okay, and we are slowly going into the code. But first I want to talk about the landscape of Python's visualization libraries. You see this purple area here, the graph, and you should focus on this one, Matplotlib. All the other libraries are connected to Matplotlib, like Seaborn, Pandas, etc. It means they depend on Matplotlib. If you get comfortable with it, you will have, your job will be much easier. There are nice JavaScript libraries as well, and some of them have Python interfaces like Bokeh. If you want to create interactive charts, chances are you will end up with using Bokeh. That's what I do, actually. And I placed here the links to the official materials. So I think these official materials are better than Stack Overflow. First, you should check these official documentations, and then Stack Overflow. That's my recommendation. A typical Matplotlib chart will look like this. Obviously, you will have an X variable and a Y variable. Over here, you are looking at the total number of rated films in IMDb dataset. And you see immediately drama and thriller movies are the most famous ones, let's say. However, if you check the second one, all of a sudden sci-fi and adventure are going to the top, because the second one is showing the percentage change in the total number of ratings over time. And that's why I say focus on your goal before you start, because it depends what you want to show. Both of them are using the same data, but showing different things. Are you a producer trying to get funding for your drama movie, or are you trying to convince people for your sci-fi idea? Anyway, if you want to dive deeper into this analysis, you can follow this link and you can ask me more questions later. Okay, we are almost there, but I want to show you also this one. Depending on your audience, you may want to show also the distribution. This is again from the same data, the one on the left and on the right. However, on the left-hand side, you are looking at the point averages. And on the right-hand side, you are seeing their distribution. These are the wages of waiters in different groups. And the point is, okay, the group A is earning more on average. However, there are people in group B, C, D earning more than these people. So depending on your audience and your goal, you may want to do this. And the full article's link is over here. I recommend checking that out as well. Okay, we talked about several libraries, how to decide which one to use. First, I want I want you to focus on Matplotlib for sure as a beginner. And if you want more shinier, maybe more beautiful looking charts, then you can use Seaborn. It is newer and more modern. And the good thing is it's an improvement on top of Matplotlib, and you can still use Matplotlib functions in Seaborn. Similar with Pandas, if you are using Jupyter notebooks and you are analyzing your Pandas data frames, you can use some quick functions to call Matplotlib visualizations into your Jupyter notebook, and we will try these out in a few minutes. For interactivity, I recommend Bokeh library. I used Plotly a few times. I didn't like it, but it can be personal. Maybe it is better. I don't know. Okay, before going into the code again, I want to highlight something. So in Matplotlib, first we create a figure. It is the big rectangle over here. And then inside of this figure, we create axes. And only inside of this axis, we place the X and Y variables, and then we plot it, basically. That's how it works. And this is the kind of code we will write today. This first code over here is creating that rectangle figure and the axe inside of it. And then the developer will populate this axis. This is totally optional, but I wanted it to be here. Later you can use this because sooner or later you will start taking these kind of decisions also, what kind of color gradient to use, what kind of colors to use for your audience, etc. First things first check the official documentation. However, there are some useful web applications that you can use also. I placed them here. This one is a newer one, and you can copy paste the color codes directly from here to your Matplotlib application. I like Color Brewer also to check how things would look like. So you may find this useful later after having some experience. Okay, enough talking. Now let's start using our data, the UFO. I have this small project here. I will start my terminal over here, the UFO talk. And I have here the clean.py file. We will use this to clean our data, but I will not focus on this one. Later, I will share this code with you and you can play with this yourself and see what kind of cleaning I am doing. The data will be in the data folder and it's a CSV file. Let's start a Jupyter notebook and start the coding. All right, we need a notebook. And first I need my imports. I'm going to import Pandas first, and then NumPy. And for visualization, Matplotlib. Pyplot as PLT. Pandas and NumPy is used for data processing and Matplotlib for visualization. Before reading the UFO data, I want to show what I was telling in the slides. So we need a figure and axe, right? So the way we do it is you create a figure and axe using this function. Subplots, not subplot, but plural subplots. That's what I meant by creating the rectangle. And then you will also have this axe object. And you can call your visualization functions. For instance, if you want to make a scatter plot, then you will call the scatter function with dot notation. And Let's draw something inside quickly, and then we will read the UFO data. So X variable can be 1, 2, 3, 4, something really simple. And the Y variable will be representing the ice cream sales, maybe. And yeah, this one. So if you run this again, you will not see anything because we didn't pass these variables to our X. And I want to call the plotting line plot function. And I want to plot X versus Y. So if we run this and in the end we say plt show, we have our data. But of course, never send something like this to someone. It doesn't have a title. You are not saying what is what. So this may as well be a mountain. So, and the good thing about Matplotlib is it is 100% customizable. You can add, for instance, a title saying set title. And I think we say, I think this was ice cream, right? Not type, but title. Okay. What if I want to plot two things in the same field, in the same figure? Then you will need two axes. So X number 1 and then X number 2. And it's going to be a tuple. And you will say that you need these two. And you will need to change this, obviously, because now you have two axes. And it will look like this because you are not passing anything to the second one. Let's quickly pass something representing the soda sales, maybe. Or let's change it a little and give a different name, maybe. If you just copy paste this, you will see it in action. The second one will be the X number 2. And of course, your Y variable is being this one. And the name of your title is not ice cream, it's soda. Great. Before reading the UFO data, I just want to highlight a small thing here. Most of the time we play with the size of the figure as well, and you can set the size with this straightforward function, set size inches. And maybe I need something 20 by 4. Finally, the first one, I just want to show the coloring. So if I need something green, then I can do it this way. And instead of line, you can use dashes. I will not go into all the parameters and all the methods you can use, but I'm trying to make a point that you can customize this totally. Nice, okay.
Hey, Shadas, one quick request. Could you zoom in on your web page there a little bit, just to make the text a little bit bigger? Thank you.
Yeah.
Yeah, that's great. Thank you.
Nice. All right. I hope this was clear. Now I want to read my UFO data. Let's create a markdown first here. Let's have a title, UFO Sightings. Obviously, first I want to read my data. So first I need to know where my data is, right? I placed it to a folder called data ufo.csv. This is the location. I'm going to create a variable called df, representing data frame, and I will use the Pandas read CSV function to read the CSV. I will simply pass this read path to this function, and I want to use here the on dead lines, because there are some corrupted lines in this data and they are not relevant. I will simply skip them. And to avoid irritating warning message, I will just use another parameter here. It is the low memory. Oops. Great, so we didn't get an error message. It means we have our data frame. Let's check how it looks like. We have the date time of the UFO sighting event, and people are seeing these UFOs and they are reporting it to the authorities, and some people are recording that, obviously. I don't know who. The date time of the event can be different than the date posted. So this is the date posted to the database. And the city, state, country, these are locations, and shape of the UFO is encoded here. The duration of the event, there are some comments as well, and there is also the latitude and longitude of this place. We call this info function. We get some basics about our data, like we have 88,679 records in this data. Okay, let's start visualization. But before starting the visualization, I mentioned that I have a cleaning function and I want to import it and use it. So from clean, import prep data. This will take like 8 seconds. I think the last time I was running it took like 8 seconds. I will create a second data frame. This is the cleaned version of the first one, and prep UFO data will be using the first data frame, and it will create the second one. And I am actually going to use the df number 2 in my visualization.
Can I ask shoutouts what that prep UFO data function does? Does it just look for bad data or bad rows, or what's going on in there?
Yeah, I will share this with you, and you can also play with that later. However, I am not able to see my browsers. I want to click on it.
You can drag that little floating zoom window out of the way.
Really? Oh, thank you.
Yeah.
Okay, this is the clean. So I got it from a friend. Actually, I didn't write it. And this is her LinkedIn profile. And it basically transforms some date time entries, and then it changes some data types, and it creates some additional columns like month, year, date using this date time column.
Got it.
That's what it does. And it looks something, and it looks like something like this in the end. So let's check the head of this clean data. So the difference is this date time now is properly parsed into date time objects, and some of the variables, some of the corrupted lines are cleaned, and some new variables created. For instance, think like year, date, hour. Okay.
Nice. Yeah, just making the data easier to work with.
Yes. This more tidier, let's say. Yeah, I like that word, tidy data.
Yeah.
So this, let's ask a question and try to answer it. This is a recommendation again. So first have a question in your mind and then start coding, not the other way around. You will be much more efficient this way. So the first question that I want to explore is the locations of events. And I think about using the latitude and longitude to do that. And I want to explore how they would look like on a scatter plot. How to do that? Okay, we already discovered how we create a figure. Let's start with that. So my figure and axis will be PLT subplots. And we know that this gives us an empty canvas, let's say. And I'm going to need an X and Y variable. In this case, my X variable will be the column of longitude. This is how we select columns in Pandas. Longitude is X, and the latitude, I hope I am writing right. And then we know that we have access to many plotting functions using this X. If I call the scatter function and pass this X and Y variables, and in the end say plt show, let's see what it gives us. Obviously, this is not the final thing that I want to see, but it is nice that I am not getting an error message. Obviously, this left-hand side is looking like Americas, but let's make it larger first. I want to set size, keyboard inches. So I need something 20 by maybe 12. But this looks much nicer, in my opinion. This looks like the world. And we see that the majority of the cases are from the US. Maybe the people who built this database are in the US. Finally, I want to set my title to, I don't know, UFO sightings. What's nice about these visualizations is that you can directly right-click and copy to your presentations, to your emails, to wherever you want. You can, of course, also save it. It's easy to share.
Can I ask one more question there, Cagdas?
Mm-hmm.
When you create, for instance, right there on the top of line 23, where it says fig, ax equals plot dot subplots, what's the distinction between fig and ax? Is fig the actual kind of box, the figure, and ax is the data within it? Or why the two variables fig, ax?
Yes. So this function creates two objects. One of them is fig and the figure, and the other one is ax. So it creates two things. The figure is the empty rectangle, and the ax is the axis inside of it.
Got it.
Like this one. The first one is the figure, the big rectangle, and it is the empty canvas. And the second one is the ax. The axis is the one inside of it. I hope that was clear.
That's why when you're, for instance, when you're setting the size of the image, you're saying figure.setSize, and when you're setting the data, you're saying, for instance, ax.scatter. Okay. Thank you.
Yeah, thank you too. Yeah. Okay, with this, we answered our first question. These are our locations, the UFO sightings. And let's formulate another question by first creating a markdown and formulating our question here. Now I'm interested in the top 5 cities. And I want to see it in a bar chart. But how to do that? First I will create a group by, and obviously I will group by cities and count the records. And in the end, I will take the top 5 cities from this group object. Okay, this sounds like a plan. So if you formulate what you will do like this, then you will enjoy it more, in my opinion, and you will be more efficient. I can't highlight this enough. Okay, how to create this group? Okay, there are many ways of doing this, but I will just go ahead and do something straightforward, in my opinion. First, I will select the columns I need, so to be more explicit. So I will need the city, but I don't actually remember what the name of the variable was. So let's call the head function first. I just need 2 rows. That's why I passed 2 here. So the name of the variable is actually, name of the column is city, not cities. So I will select city and then date time and quickly group by city and count. One thing you will face during the visualization projects is that you will spend most of your time on reshaping your data. This is a small example of that. This means there are 22,000 unique cities in this data, and these are the total number of records over here. But I want to sort it, and before sorting that out, I want to change the name of this column quickly, because I don't want to see it as date time. It is misleading. We have a convenient renaming function like this, and we can pass a dictionary. So I want to change the name date time to CNT, representing the count. And this became more difficult to read. One recommendation is to use this kind of notation. This will help you a lot, in my opinion, especially if you revisit your code.
Shadash, I have
Look,
a question.
You can break this. Yeah.
Yeah, I had a question as well. You've had the DF2 thing, but you're only using DF here.
Oh, thank
I'm
you.
wondering if that's is that an oops? Okay.
Yeah, it was a mistake. Yeah, I have to use DF2. It didn't change the data frame, but obviously I was using the wrong one. Okay. The last step in this reshaping script is sorting. So I want to sort the values, and I need to pass the name of the column that I want to sort. Let's see how it looks like. Okay, we can already see the top 5. However, I want to see them on the top, not at the bottom. So it means descending, not ascending. So the ascending should be false. And if you do this, yeah, they are on the top. And a final touch would be taking the top 5 using the head functions, because head function gives the top 5 by default. I mean, the first 5 rows in your data frame. That's it. And now I will name this cities. Great. And plot bar. Now, what the hell is going on here? I talked about lots of concepts like figures, axes, etc. All of them have disappeared. What did I do here? I just used Pandas interface for Matplotlib. It was also in one of our slides here. So for quick plots, Pandas is great, especially if you are in Jupyter Notebooks. I passed this plot function and I declared that I need a bar chart, and Pandas immediately understood what I am trying to do, and it gave me the bar chart that I need. And I don't know what's going on with these cities, but people reported a lot of UFO sightings from it in these cities.
I can tell you some of them. Seattle is where Boeing is located. And so Boeing does a lot of military stuff. Phoenix is down in Arizona, and that's near where Area 51 and a lot of those things are. Las Vegas is out in the desert. You know, LA's got a Navy base there. Portland, yeah, Portland's just weird. But
Yeah,
I can almost
Portland weird.
yeah, I can almost guarantee you that Seattle and Phoenix are there because of A, Boeing, and B, the military bases that are down in the desert in Arizona.
Amazing. I had no idea. Thank you for insights. Okay, I want to highlight something here. Okay, we use Pandas interface for this visualization. However, you can still continue using Matplotlib functions. For instance, if you want to set a title, you can still use the PLT title and say something like this, top cities. And if you prefer doing it inside of the same script, then it's also possible. So the same thing will work like this.
And
So
one additional question, in the comment, the line that you commented out, plt.title, that PLT, that's not a variable you've defined, but is it just because we're in the same section here in the Jupyter notebook that it knows that you're that PLT?
It knows about PLT because I imported
Oh,
the
got it.
library
PLT.
as PLT.
Got
Yes,
it.
I have access to all Matplotlib functions using the PLT dot notation.
And so when you do plt.title, it'll only speak to the most recent plot or graph that you have?
Yes, this is a Jupyter trick.
Okay.
Yeah, Jupyter is really smart about these things, and it makes data analysts' life really easy. Okay.
Got it.
So now we know the top 5 cities. Now I want to explore another question. Let's create a markdown. First things first, we need to formulate what we are trying to do. Time of sightings. So I'm interested in seeing the years. I want to do a time series here. Line chart. And then I'm interested in seeing the weekdays. So is it Sunday, Monday? When do they come? And this can be again a bar chart. Next to that, I want to see the hours. So when do they come? Which day, which hour, most of the time? Again, this is going to be a bar chart. But this time I want to use Seaborn, another library. Let's first import that. Import Seaborn as SNS. Seaborn is another library that I mentioned in the slides, this one. This is a library, an improvement on top of Matplotlib again. It is more modern, shinier, more beautiful, I would say. And it is totally customizable using, again, Matplotlib notation. And the good thing is it is straightforward to use its plotting functions as well. So when you say something like SNS line plot, and if you pass some X and Y variables together with your data, it will give you a line chart. Let's see how we can do that. I think I will first copy paste this because I will again group by years this time. So reshaping will be necessary. This time, instead of cities, I will group by year. Again, there are many different ways of doing this stuff. This is just the way I use here. I want to count the records. Again, I can rename it. I don't need to sort, and I'm not interested in the first 5 rows. Let's run this first and see what it gives. Okay, so I thought that it was starting from 1946, but actually it is 1906. And it comes until 2014. There is an interesting thing here. So the records are until the middle of 2014. So actually we shouldn't use it. In order to select that, we can use the log notation in Pandas. So over here, I am simply saying that give me all the records until 2013. This looks like slicing the lists. In this case, yes, it will give me a time series until 2013 with the number of records. Let's call this year group and then see how it looks like. Yeah, this is the one I want to pass to Seaborn. And I already mentioned how we can do that. So the line plot function in Jupyter Notebook, if you are confused about what kind of methods, parameters you can pass, you can simply use the Shift tab and it will open up the help documents. And then you can read what to do. So it needs an X, a Y, and this hue is about the color. The most important one is the data. You need to define what your data frame is. This is the different part maybe from Matplotlib. So let's pass these variables. My X variable will be the year group data frames index. So this part is called the index of the data frame, the year. And the Y variable will be the same data frames, C and T column. There are two kinds of notations in Pandas. You can select the column using this notation or this one. And my data will be the year group. Okay. Let's see if this is giving an error. It's fine. Maybe it is a bit small. Let's configure the figure size again. This time I will use the PLT figure. And size. I will pass a tuple of 2 integers saying that I need something 20 by 5, maybe. Okay, looks much better this time. The interesting thing is it rapidly increases after 1994. And this is really something curious. I don't know what has happened after 1994. We are observing exponentially more number of UFO sightings after this year, somewhere around 95. Some of my friends told me that that was the year the TV series X-Files started streaming. And that's a TV show about UFOs and abductions, etc. It may have an effect, but I'm really not sure. It's just a possibility. And maybe it affects people. It's again customizable with Matplotlib functions like this. You can still use them. So this was about the years. So weekdays. Weekdays will be trickier because I think we don't have weekdays here. I mean, readily available, but we can extract it using the datetime column because this day is the day in the month. The way we create new columns is, I mean, one of the ways we can use is like this. So this means all the rows and then give me a new column called weekday, maybe. This will be EF2, the datetime, DT. DT accesses the datetime operations. And I think there was this function called day of week conveniently, but I'm not sure. If it fails, yeah, we will check the documentation. There should be a function like this. Okay, maybe not day of week, or maybe it is. I am checking what it did. Okay, yes, here we are. And actually what we ended up with is, if I check what kind of records I have here, value counts is a convenient function that I can use. So days are encoded from 0 to 6. For each day, there is one integer, and it starts with Monday. From Monday to Sunday, days are encoded like this. So I will group by with this weekday first. I'm going to copy paste this grouping function because we are running out of time. This time I will call it weekday group maybe. And this time I will group by weekday and again count the records and rename the date time again. I don't need this. I could, but anyway. Yes, so I want to focus on the visualization here with Seaborn. I will not convert these weekdays to string representations like Saturday, Wednesday, etc. But later, when you get this notebook, you can try that out yourself. Let's call a bar chart using Seaborn. It's going to be straightforward. You just call the bar plot and pass your X variable as weekday group, and your index will be your X variable, and your Y variable will be the count. Okay, and you need to pass the data. So which data frame you are using? This one, weekday group. And let's see what this gives us. Okay, they like visiting on Saturdays. So after 1994, Saturdays, and in those cities, we are observing most of the UFO sightings. One thing I want to highlight here is that Seaborn passes some colors to these bars. Depending on your audience, you can get this question, you know, what these colors represent. And in this case, it is just trying to be nice and beautiful. But you may be more conscious about what kind of colors you want. In that case, you can use the palettes available in Seaborn. One of the palettes I use a lot is this one here. It is going lighter and lighter as the values increase in this case. And it should be in my favorites actually. Seaborn color palettes. You can learn about these color gradients and color palettes using the official documentation. For instance, Rocket is the one I use a lot. Okay. And okay, what we answered one more question, I guess. So this is the day, the most famous day, Saturday. And the third one we asked was the hours. Yeah, I will use a similar approach here. Instead of weekday, let's use the hours and see when the UFO visits us most of the time. I think I have the variable ready this time. Yes, our column is here. What I need to do is just pass the hour here, and maybe rename the variable our group. How does it look like? Okay, nice. And let's pass another bar chart to see when they visit. This bar chart was really small. I want to create something larger again. Figure, object, and it takes this fixed size tuple. Maybe again 20 by 5 or 6, I don't know. PLT show. Let's use also one last time PLT title. the visiting hours. Okay.
Don't forget to change the data inside the bar plot as well. It's still using weekday
Uh-huh.
group.
Oh, thanks. Yeah.
John with the eagle eye today.
Thank you. Yeah. Okay. So these are the most popular visiting hours by the UFO. After 1994, on Saturdays after dinner time, they like visiting. Now I want to make a recap. I want to review what we did in this notebook. First, we talked about the fundamentals of Matplotlib, how to create these objects and plot variables. And then we were reading our data using Pandas and cleaning. After we have seen how to make scatter plot with Matplotlib, and then we checked the top 5 cities using the Pandas Matplotlib notation, quick charts, remember? And then we started using Seaborn. We created new data sets. We reshaped our data into groups and we used them in our visualization applications. First, we did a time series, and then we did 2 bar charts showing the week of the day and the time of the day. So yeah, this was all I wanted to share actually.
Well, this is really cool. One question I have is, can we take a quick look at the raw data? Is it a CSV file, or like, what does the raw data look like?
All right.
So and you said there's how many, 44,000 rows or
More than 80,000.
80,000 rows of total gibberish, as far as I can tell. And in less than an hour, we're able, using Matplotlib, Pandas, Seaborn, we were able to immediately figure out what this data means. I mean, it's really impressive. It's so cool that we can do this, and that it's relatively straightforward. Once you learn the tools, we know that, and now we can start to make some really educated assumptions after X-Files started on the weekends when most people are outside. In the evenings, I'm thinking barbecues. As Karel mentioned, there might be some beer or wine involved. It's a Saturday afternoon, and we can start to really understand the nature of UFO sightings around the world. It's so cool.
Yeah, and in U.S. cities that have either Air Force bases, U.S. Air Force bases close to them, or major airline and aircraft manufacturers near them. So
yeah, that's the expert knowledge.
Yeah.
Very, very cool. Does anybody else have any questions? I mean, Cagdas, you've done a fantastic job of walking us through this and making things clear and understandable. But are there any other questions? I know we've been chatting in the sidebar, but it's been mostly kind of comments and some jokes and links. But any questions or things that anybody would like to ask? You just did that good of a job, Cagdas.
Jeez.
So how long have you been working with these tools? Just to like, how long would it, let's say somebody's just getting started, they're pretty familiar with Python and they're trying to learn how to use these tools, Pandas, Matplotlib, Seaborn, etc. How long have you been working with them?
Well, I'm using Python on a daily basis since 2018, 17, I guess. However, becoming good with these visualization tools is, I think, straightforward, because these people already implemented a lot of best practices already in these libraries. If, for instance, selecting a palette, selecting some subset of the data, these are really these days straightforward. And if you compare the kind of effort you need to give, for instance, to machine learning, let's say that you want to become a machine learning expert, and on the other hand, you have these visualization tools as well, I think you will become pretty good at visualization tools in a very short time compared to machine learning. And its impact is really high because 90% of the time in a business setting, the business leaders first need this kind of visualization and summary statistics, and your impact will be really huge. I hope I could give some answer.
Yeah, that makes I get what you're saying. Basically, these tools are relatively straightforward to learn, easier than, for instance, machine learning. But the good news is that when you learn these tools and you can use data visualization and data cleaning and data transformation nicely, it's got a really big impact and it's really valuable.
Yeah, thank you.
Yeah.
that was it. Yeah, that was it. Its impact is really high compared to the effort you will spend.
Right. Nice. A couple of comments. Rico mentioned, will we get this recorded session somehow? Yes, Rico, we will upload this to our YouTube channel. I'll share the link here in the chat, and we'll also share that on our Slack and forum when that's up. And everybody says thank you. Rico, Scott, Tabitha, Corel, everybody says fantastic job. Shadas, thank you. That you really did do a nice job. So and I would add to the thank you. That was really nice.
Yeah, it was my pleasure. It's great to be with Coding Nomads.
We love having you with us.
Yep. With that, I know we're a little bit over time. We're going to let you guys go. Keep an eye out for the video coming. And if you have any other questions, you know where to find us. Shadash, thank you again, and we'll see you guys in 2 weeks.
Hey everyone, thanks for watching. If you enjoyed this video, please let us know by liking and subscribing. If there's another topic that you'd like to learn more about, leave us a comment. We would love to hear from you. And if you want to become a coding pro, visit our website at CodingNomads.co. See you next time.